Okay, so what we want to do is we want to be able to add or subtract like terms. So before we can do that, you need to know what a like term is. So um, here I've written in some notes here. So you want to know what is a term and then what is a like term. So there's a few things I just want to fill in details with. So we'll go over to some equations and expressions here. Now, you also want to know what an equation and expression is. An expression is where you get given some letters, numbers, and operators. Plus and minus are operators, and you have to simplify it so you join together what you can or subtract and make it as simple as possible. Expressing, notice this expression here that I've got. It has no equal sign in the expression. It just has the expression. Now, an equation will have similar things as an expression. It'll have letters, numbers, and operators, but it'll be equal to something. So it'll have two expressions, one expression on one side and another expression on the other side. So they have to be equal. Whereas if you look at just an expression, it's filled with terms, but it's not equal to another expression. So let's have a look at the difference. An expression has terms, so 2b, 3a is a term, and a is a term. How do I know which are terms and which are not terms? They're separated by operations like plus, minus, times, subtraction, things like that, or division. So when you have terms, they're separated by the operators in maths. Okay? So over here we have the difference in equation and expression. An expression is a combination of numbers, variables, they are letters, and operations like plus or minus. They don't have an equal sign. Whereas an equation is two expressions with an equal sign saying they're equal to each other. So we have two expressions. We have the 2b minus 3, and that is equal to 17, which is a term there. So one term's on this, one expression is on this side, and one expression is on this side. And they're all, remember, expressions are made up of terms. So 1, 2, 3 terms. And they've got operators in between. Anyway, that's sort of trying to fill in your knowledge there. So what is a term? It is the letters or numbers that are separated by operators, okay? And so we have the equals operator there is separating that one from the ones on this side. Because it's got an equals, it means it's actually an equation. Okay, so expressions have no equal sign usually. They just like this. They might have it. They sometimes might do this. Equals, we have to simplify it and then put the simplified answer on the other side. But they won't have any actual answer on the other side. So it won't look like that. Okay, it might look like this. But usually, sometimes they don't even have an equal sign. Okay, anyway, that's an expression. So what is a term? It is any numbers or letters that are together. It's separated by that. So what is a like term? Now, this is very important. What is a like term? So we've got 2b here, and we've got 3a here, and we've got a here. So they're all terms, but what are like terms? Okay, what is a like term? So that's pretty important. So I'm going to draw that for you. Oh, let's zoom out a bit. Let's move that out of the way. Need to move that out of the way for you. All right. So what is a like term? Now this is a really important concept. So a like term. So if we know that 2a is a term, and then I'll separate it by operator, and a is a term. Okay. Are they like terms? Well, a like term has to have the same letter, and it has to have the same power or exponent. So here's we'll just leave this one here at this part here at the 2 out for now. That's called the coefficient. So this letter here is the same letter as this one here. They're the same letter. So if a like term has the same letter, that's one of the things it has to have, but it also has to have the same power. So this is A, and there's no exponential power there. If there's no exponential power, that means it is a 1 there. Okay? You just don't write it. And if there's no exponential power here, that means that's a 1. So are they the same letter? Yes. Are they the same power? Yes, they're both A to the power of 1. So they're like terms. If you put a number in front of it, like a 2 in front of it, and maybe a 3 in front of this one, they're still like terms because they've got the same letter and the same power. Okay, so 2A, if A by itself is like the same as 1A, isn't it? It's 1A. If we thought A's equaled apples, you could say there's 1 apple. Yeah. But I'm not going to use apples as an example. I'm just saying you can see that the 1 in front of it, you just don't write it. There's one of them. Now, 2A's means there are 2 A's, literally. So 2A plus 1A plus 1A would be exactly the same as 2 A's. So let's have a look what it's happening. We've got A plus A, which is the same as 2A, and then I'm minusing an A. What am I going to be left with? If I've got 2 A's and I take away 1A, there's going to be just 1A left over. Yeah, 1A left, because there's 2 here and I take away 1, so there's only 1 left. So what about this? I've got 2 A's here and I've got 3 A's here. So what is this? This is A plus A. Yeah, A plus A. Awesome. That's like 2 A's. And this is 3 A's. A plus A plus another A. Okay? Yeah. So there's 3 of them. Now, instead of writing it like this, like that, you just put 3 in front, and that 3A means the same. I've added 3 A's together. So remember, if these were apples, individual apples, how many apples have I got? I've got like 3 of them. So you're just saying I've got 3 apples or 3 A's. And remember that power bit? That's pretty important, okay? Because this is, if A stands for apples, A to the power of 1 stands for apples, then I've got 3 apples. Great. Over here, I've got A to the power of 1, and remember that stands for apples, so I've got 2 apples. Now, can we add these together, these apples? Yeah, if I put a operator in the middle like a plus, how many would I have? I'd have 2 of them over here and 3 there, so I'd have 5, wouldn't I? Yeah? I'd have 5 of them. There'd be 5 of them. Yeah? But we'll just say, instead of writing A plus A plus A 5 times, we'll just say there's 5 A's. So let's put a little plus there and see what happens. So I've got 2 here, 2 of them and 2 there, and I add 3 of them, and what have I got? Yeah, I've got 5 of them. 5 of them. So that's fine. So, okay. So, I can add them together. All right, so let's see. What is a term? Remember, it's when you've got numbers of letters separated by an operator. Now, if I change this, if I rub that out a bit, and I'll just rub it out with a rubber. Okay. And I decided, instead of putting a plus there, I put a minus there. Now I've got 2 of them, and I take away 3 of them, so that means I've actually got less than 0 now. I'd have like, I wouldn't have, so if I had $2 in my bank account, and I took away $3 out of my bank account, I'd have negative $1, wouldn't I? So now I've got negative A. Negative 1A. You just don't write the 1. Okay, so this might be getting a little confusing for you, so I'm just going to rub this out and just make sure you get the idea of what is a term. So we worked out that if it's the same letter, so same letter, regardless of the number in front of it, if it's the same letter and the same power, remember if there's nothing written there, it means it's a 1, then they are like terms. And that means you can add or subtract them together. They're the same. They're like. But what happens if I've got the same letter, but I have a different number? Okay. What happens if I've got that, and I've got another one over here like this, and it's got 3, and I've got another one over here, and it's got the same letter, but it's got a different number. It's got no number, so we know it's a 1. Now, are they the same letter? Yep, they're the same letter. But have they got the same power? No. So they've all got different powers. That's got 2, that's got 3, that's got 1. So can we add them together or subtract them? No. You can't. Okay? So you can't add them together. You can only say there's 2a to the power of 2. Yep. And there's a to the power of 3, and there's a, and they're all separate, and you can't add them together. Here, this is to the power of 1, and this is to the power of 1, so we can add these ones together. There's 2 of them, and I've got another one, so there's 3 of them, or I can minus them. Okay, so that's fine. Remember, if it's a different power, even though it's got the same letter, you can't add them or subtract them. You can't. They've got to be separate. Okay, so there's the second rule. Now let's have a look at another example of different ones. So just to make sure you really get it, because once you get this rule, it's pretty easy stuff for you. Okay, so here we go. We've got an A, and we'll say 2 of them, and I've got a B, and I've got a 2b squared, and finally I've got an AB. Okay, now let's see. Now let's use the rule, because it looks pretty complicated, but I just want to go through it and use the basic rules. Now, do they have the same letter? So does that one there, A, and that, do they have the same letter? No. So we definitely can't add or subtract these together. They have to be separate. Which means if I was trying to simplify this in a thing, I would have to write 2A plus B. I can't add them together. I would have to leave them exactly the same. I couldn't add them together. They're completely different. That's an A and that's a B. Can't add them together. So can't change it. Okay. So let's just that's easy, eh? The letters are different. Great. Okay, so over here, we've now got another example. We've got I look along here, I've got an A, a B. This one I've got a 2B. Now, letters are the same, but this one's to the power of 1 and this one's to the power of 2. So can I add these two together? These two together, can I add them? Or subtract them? In this case, it's subtract them. Can I? No, the letters, that's to the power of 2, that's to the power of 1, so we can't leave them. They have to remain the same. So if I was given this question, I'd have to write B minus 2B squared. Couldn't add them together, okay? They're different. Okay, so that's that one. What about this last one along here? I've got AB. Right, so that there's A is the same power as that. Awesome. So can I add 2A with AB? Unfortunately, no, because it's AB and not just A by itself. This AB is totally different to that A and that B. They're not the same. This is called AB. Just like if I added one more and I called it A squared B squared. This a squared, b squared is totally different to this ab because it's the same letters but different powers. So can I add these two together? No, can't do that either. Boom, can't. What about this a squared and this a? Oh, no other a squared, can't do that. What about this b squared? There's a b squared over here, but it's not an. There's a b squared. That's awesome. That's the same as that, isn't it? But problem is this one's ab. This is ab together. So can we add, since this is not AB, this is just B squared by itself. So the whole thing has to be the same, okay? Yeah, so that is, that's the reason why that's not going to work. Okay, so anyway, let's move on. So that's like terms. Like terms have to be the same letter and they have to be the same power. The number in front, the number in front of the letter, it doesn't matter. And you might have noticed something. If I go 3, maybe x, we'll do x's. That. And I've got 2 x's. Like that. Notice when you're trying to get your answer, find out simplified, say it was, we'll do plus again. If I'm simplifying these two, trying to get a simpler answer, all I'm really doing is adding out the number called the coefficient. I'm just adding them together, so that it's all I'm doing is doing that. Yeah, do you see that? Yeah, interesting, eh? So that's see the number in front is basically what the answer is going to be. See how the x's are staying the same power to the power of 1 to the power of 1. So the answer is to the power of 1. I'm just adding the numbers in front, really. Yeah? Okay, we'll do one more so you sort of get it. Okay, I'm just going to rub it out. Okay, so if I did this, x plus x, x plus x, what numbers in front? If I am adding the numbers in front, then that's going to be the answer. So if there's no number in front, what's actually the number? Well, if there's no number written in front, it actually means it's 1x. 1x. Okay? There's no number in front. So that one there is going to be what? A 1x as well. So what's our answer going to be when we've got a 1 and a 1? 1 plus 1? It's going to be equal to 2, isn't it? So notice the letters are going to stay the same. They're not going to change. They're just going to still be x's. So I'm just adding my x's together. Right. Right, let's do a harder one so you can sort of see this, because if you don't get this, this is where it gets really tricky. Okay, say we have a different power. Okay, so I've got x to the power of 2, and I'm adding 2x to the power of 2. Remember how I said the number in the front is the bit you're adding or subtracting? So remember, what's the number in front of the x? It's a 1. So the number in front of this x is a 2. So when I add them two together, a 2 plus 1, that's 3, isn't it? So it should be just adding the number in front. And since there's not a number, we know it's a 1. Okay. And so we're just adding the numbers in front. Is the x's and the powers changing? No, they should stay exactly the same. It just stays exactly the same. So that part there, and the letter in the power, it should be exactly the same in the answer. Okay, it's not changing. So that what's the only thing that's changing when you're adding or subtracting? It's the coefficient, the number in front of the x's is the only thing that changes when you're adding or subtracting. Okay, hopefully that makes sense a little bit. We'll go to some examples so you can really try to master it. Okay, so already So you're asked to simplify an expression and you don't know the answer. So, oops. So you're told, oh, oops. Okay, so you're told to simplify an expression. So you don't know. You've just got a plus a. So a to the power of 1 plus a to the power of 1, and you know that you're just counting the number in front of them, which is a 1. There's a secret 1. There's a secret 1 in front of it. It's not written. So you're just adding the number in front, and the letter and the power is staying the same. So there's going to be 2 of them, and the letter stays the same. Okay, so let's count this one. This one's got 2 in front of the A. This one has a 1 in front of the A. We don't usually write it though. So you add the 2 and the 1 together, and that gives us 3 of them. And remember the power and the letter doesn't change. It stays the same. Okay, so we've got 2 A's. We add them together, and now we've got 4 of them. Now, if this was subtracting, say you got 2 A's and you minus 2 A's, what would be left over? They'd all be gone. They'd be gone, wouldn't they? If you imagine if you had $2 in your bank account and you took away $2, you got no more. Okay, so plusing or minusing we'll have 4 A's. Right. So remember, if the powers of this are different, they never change. You can only add or subtract like terms. So I couldn't, if this was a B, could I add 2 A's plus 2 B's together? No, I would end up with 2 A's as my answer, plus 2 B's as my answer. Can't add them together because the letter's different, or the power is different. So if this was A squared and A, couldn't add them together. Okay, hopefully you're getting that. So over here we've got A and plus B, and our answer would be A plus B. Yeah, that's right. Because you can't add them together. Now we've got 2 A's plus 2 B's. What are we going to get for our answer? No, we can't add them together. So you should actually just have to put, there's only 2 A's and B's. Can't change that, okay? So hopefully that is starting to make sense. Let's go down to another one. Simplify this expression. I've got 5 A's and I'm minusing 2 of them. So what numbers, remember, what are we dealing with? The number in front. So there's going to be 3 left over of A's. Awesome. Okay, simplify and add and simplify expressions. That's basically the first skill that you want to be able to do. And we'll move on to the rest of the skills that you need to do in the future.